I think you turn to page 32.
Just two. Wait, is this the is unit three only these?
Right.
So
Unit 3 only has 2 additional topics, and the rest of the time we're just reviewing.
yeah, that makes sense. Thank you.
All right, so we have one more topic to go over. And then we can maybe have time to begin our quiz review. Quiz will be on Tuesday. But we still there's still a little bit more particle motion steps out or types of problems I want to go over with you. But I think we can also begin our quiz review. So far, we just learned power rule, but there's also something called product rule and quotient rule. And this is when you have problems that are more complicated in the sense that if I have 2 expressions that are being multiplied together and I want to find the derivative of both those, find the derivative of this overall expression, I have to go through a product rule. I can't just say, oh, f prime times g prime, and that's my derivative. However, we do involve both f prime and g prime, but because of the multiplication, we have to go through a little bit more than just f prime times g prime. Now, if the function was f of x plus g of x, then we can find them independently and there's no issue. It's just f prime plus g prime. But if I have 2 terms being multiplied, I have to go through this, this rule here. So the rule is they're basically taking turns being the derivative. So here it's the first function's derivative times the second function, original function, plus the original first function times the second derivative. So we say f prime g plus f g prime. F prime times g plus f g prime. F prime means derivative, and f would just be the original function. So here's example 1. We have 3x minus 2x squared times 5 plus 4x. So usually, whatever I see first, I'm going to assign as my f. Whatever I see second, I'm going to assign as my g. Technically, we could avoid a product rule here if we expanded everything out and just relied on power rule. That's also an option. But later on, when we introduce different families of functions, we can't just distribute, and we're going to have to rely on this product rule. dy dx is another notation for derivative. This is basically the same thing as y prime or f prime of x. Dy dx means find the derivative of my dependent variable y with respect to my independent variable x. So this is another notation for the derivative. So if I want to find dy dx, so y becomes dy dx or y prime. They're all talking about the same thing. So I'm going to just set up what I need to find. I'm going to have to find f prime. Then I have to multiply that by g. Then plus back to f times g prime. So we're just going to take turns finding the derivative and value for each term here. So what do you think f prime would be if f is 3x minus 2x squared? 3x becomes 3 minus 4x. Yeah, so that will represent my f prime portion of my derivative times the g function. So g function means don't make any changes, just copy down exactly what you see. Back to f, no changes. And then g prime was the derivative of 5 plus 4x. Just 4, yeah, because 5 goes to 0 and 4x becomes 4. So this is our derivative. So whatever we plug in for x into the derivative, in return, it's going to get us a number, and that number will tell us how steep that point is on this curve. So, as messy as our derivatives get, basically they still do the same thing. They're just describing the slope of some original function. Technically, we could expand all this out and clean this up, but for now, we're just going to be okay with the derivative in uncleaned up version. Next up, quotient rule. Quotient rule is if I'm trying to find the derivative of two expressions that are being divided by one another. Here's the formula for quotient rule. It's going to look a lot like product rule. There's still that f prime g and fg prime, but instead of a plus, I'm going to have a minus between the two expressions. So it's going to be f prime g minus fg prime. And then here's the additional step. We got to divide it by the original denominator squared. So divided by g of x squared. Okay, so here's example 2. 3x minus 2x squared all over 5 plus 4x. We want to find the derivative of the slope formula for whatever this graph looks like. So I'm going to assign the top portion as my f, and I'll assign the bottom portion as my g.
That's y prime.
That's y prime. Yeah, sorry. Yeah. So this one's asking for y prime. This one's asking for dy dx, but they mean the same thing. Just finding just all these different notations for derivative. Okay, so y prime equals. Let me set up and label everything that we need to find. F prime times g minus f g prime all over g squared. Okay, f prime, just like how we did with product rule, 3 minus 4x. G function, no changes.
You saw the negative because the.
You mean why is there a negative here? Or yeah, so that's just part of quotient rule.
Right there.
Yeah, it's always going to be subtraction between the two terms. Yeah. Minus, okay, back to f. And then g prime, back to 4. Careful with quotient rule. I think a lot of students would start off with f prime g minus f g prime, but then forget about the g squared. So just remember, quotient rule also has a denominator component to finish off its derivative. So it looks a little messier than product rule because that denominator kind of adds to the complexity. Sometimes you may be asked to simplify or clean up the numerator. And we'll do that later if we need to. But technically, yes, we could clean this up by expanding and distributing, combining like terms from the numerator. But one thing just to note is that if you're cleaning up your derivative for your for quotient rule, you're largely going to leave your denominator alone. There's maybe some instances that you may be able to clean up the denominator, but your denominator is largely not going to change. Yes. For the quiz, I'm going to ask you to simplify, but I think it's going to be a little bit cleaner than this. But ultimately, you're just going to distribute, combine, and add your like terms. The reason that I say that your denominator is not going to change is because a lot of students want to, well, not a lot, but some students want to do this where they see, oh, I see a bunch of 5 plus 4x's. I'm going to start canceling out, take out one of the 5 plus 4x's. Why can I not do this? Yeah, because this is part of attached to a addition and subtraction. So I cannot cancel across addition or subtraction. Now, if this wasn't here, then yes, then I can cancel the 5 plus 4x's and I'm not breaking any rules. But usually within quotient rule, you're not going to do anything with the denominator. So just keep in mind that if you want to clean up, you're just going to clean up within the numerator. You're not going to do anything with your denominator.
Your mid's large, right?
Medium.
Jack. Let me see if I can find it.
That's okay.
Let me zoom in. Here, that's medium. Yeah.
Okay. Now, as messy as quotient rule looks, it does the same thing as other derivatives. You give it an x value, in return, it gets you a number, and that number just describes the slope of whatever graph you started with. Okay. All right, page 33. This is just some notations that I want to go over here. Sometimes you may be asked to go beyond the second derivative, but if you ever asked to go beyond the second derivative, it's usually just going to be something where it's just a bunch, you're doing power rule over and over again. So y prime, let's just go through this. Sorry that some of the numbers are kind of hard to see. So y prime, which is every term is just ready for power rule. So 10x to the fourth plus yep, minus 9x squared. Okay, minus
16x
plus
and
10. Okay, so keep going. Find y double prime, and then the third derivative and the fourth derivative. Typically, when we get down to anything past 4, we start using numbers rather than tick marks. We'll say, y fifth of x, and this means the fifth derivative. Okay, just some notations. We talked about this already, but notations for first derivative of a function, it could be f prime of x, it could be g prime of x. If your function starts with g, it could be y prime of x. It could be dy dx. Sometimes it may say d over dx of 3x cubed, and that just means find the derivative of 3x cubed, which you would just say is 9x squared. So there's all these different notations. It just indicates find the derivative of some expression. Now, notation for second derivative will be f double prime of x, y double prime of x, y double prime. And this notation looks kind of strange here is d2y over dx2. It just means second derivative. It doesn't mean that it doesn't mean you square your first derivative. So just know that this is a symbolic notation to indicate second derivative.
Yeah. Didn't you say that it's rare to go past the second?
Yeah, we're rarely going to go past the second derivative. If we do, it'll be something where it's just a power roll away. Yeah, but typically we're not going to do much beyond the second derivative. But if we want to go down to the third derivative, it'll be f triple prime of x, y triple prime, and then you will follow the same pattern here, d3y over dx3, if you want to indicate a third derivative. But again, it's going to be rare that we go past the second derivative. Okay, let's go to next page, 34, and let's see if we can practice if there's a mixture of quotient rule, product rule, and power rule. Can we differentiate them and can we apply them? So okay, 23. If you look at this function, we have to go through what? Quotient rule. Okay, so try that. Let me write the rule here. All right, give that a try. And this one, yeah, I am going to ask that we clean up. So when you clean up, you're just cleaning up the numerator. Leave the denominator alone. Don't try to do anything with the denominator. So f prime g minus f g prime all over g squared. Distribute the 8x through. Here, I just want to do it all in one step here. So if I put the 3 in front, I can just distribute the -3 one time through and not do negative followed by 3. So this will give me -12x squared plus 6, and then combine our terms. Again, leave the denominator alone. Some students want to expand out the denominator, but factored form for the denominator is going to be the preferable version if we want to do anything with it down the road. So again, quotient rule, the rule of thumb is leave the denominator alone. You're just cleaning up the numerator. So don't expand and don't cancel out. Okay, 25. 25. Again, you would use what? Quotient rule. Later on, we're going to have a rule that may be more efficient than quotient rule in certain situations, but for now, all that's available to us is quotient rule. So try that. A lot of things will cancel out because f prime for the numerator will just go to 0. Okay. Any questions with 25? All right, 27, find the derivative, but 27, all we need is what? Oh, well, yeah.
I just like a little curious, how are these much different from like some of the power rule questions we've been doing?
They're not. So here, there's a mixture of different rules.
I guess like, is there some questions that we've done on homework that possibly we could have used this, but we just said no or no?
That we could have used quotient rule.
Yeah.
Yes. So I do want to distinguish when fractional problems are power rule and when fractional problems are quotient rule.
That was kind of my question.
Yeah. So let's get to that in a second. So try 27 first, and then hopefully I can answer your question with the next problem.
Sure.
Yeah.
And then on the quiz,
Yeah.
will you specify what?
Good question. Yeah. Yes, there are going to be some problems where I'm going to say, don't use quotient rule, don't use product rule. I want you to use power rule in this instance. So, but if I don't say it, then if there are more ways to do one problem, you can choose your way to do it.
But you're going to specify. Oh wait.
Yeah. So Yeah, so let me talk about that in a second. Hopefully I can answer some of your questions. But let's look at 27 first.
There are multiple ways to do it. You tell us to use a certain way, but we like forget, we do it a different way. Would that be a partial credit?
Yes, I will specify, yeah. So let me talk about let me address some of your questions here. But let's look at 27 for a moment. Okay, do you guys get -3 over t to the fourth?
Yes.
All right, so 31, hopefully we'll address some of your questions here. 31, there is a denominator, but there are individual terms. And notice how within each denominator, there's only a single term, right? There's no addition or subtraction between two terms. So my rule of thumb is if you only, at least for the quiz, if there's only one term in the denominator, I want you to use power rule. I want you to avoid quotient rule if possible. And the way that you're forced into quotient rule is if your denominator has multiple terms that are being added or subtracted, then you're forced into quotient rule. Right now, the reason why that I'm going to emphasize using power rule for single term in the denominator is that the process we're going to learn is going to be helpful second semester. So I want to set the I want to set up so that we can do the problems later on well. So yeah, there's going to be a problem on the quiz where I'm going to say, don't use quotient rule, don't use product rule. I want you to use power rule. So 31 is an instance where there's no need for quotient rule because the denominator can just come up to the top and we can just rely on power rule. Okay, so you can finish 31.
We said don't
use quotient rule. Just use power rule.
Okay.
Yeah. Now, if 31 looked like this, if it was 10 over x to the fourth plus 3 over x squared minus 1, then you're forced into quotient rule. You can't do power rule with this problem. But if there's only a single term under each denominator, single term or single variable under the denominator, we can avoid quotient rule. And I want you to avoid quotient rule. Okay, what about 33 and 35? Can we avoid quotient rule for these two?
Yes.
Yes, yes. So notice under each fraction, there's only a single term. There's no addition and subtraction within each of the fractions, within each of the denominators. So you can bring all the variables up and just rely on power rule. Okay, any questions on this page? Okay, give you guys a moment to finish up. So once you bring all the variables up to the numerator, you get each term ready for power rule, you find the derivative, and then if your derivative still has a negative exponent standing out, then push those variables back down to the denominator as your final answer. Okay, let's go to next page here. This is top of the page. We're just going to focus on A and B. That's enough for us to prepare for the quiz. So on page 35. Okay, two-step process here. We're going to find the slope of the tangent line. So basically, we're going to find f prime, plug -1 into f prime to get the slope, and then we're just going to do point slope form. Okay. Now, if I want to find the derivative, I got to go through what? Quotient rule. Yeah, there's no way around it. That's the only way, at least for now, that's the only way that we know how to do this. So, okay, go ahead and start building your derivative using quotient rule. So find the derivative, clean up as best you can, plug in -1 to get the slope, and that will take care of part A. And then part B, take your slope, take your order pair, and then put slope form.
What point do you have to start?
I'm sorry?
At what point do you have to start reading that?
You said at what point do we have to name this f prime of x?
Yeah, it's when you start using power rule.
Oh, yes, yes. Once you begin your derivative process, then your f becomes f prime. Yeah. But if you're just in a cleanup process, like with these power rule problems where you're just splitting up into individual fractions, then it still stays as f of x. But once you begin one of your derivative process, either power rule, product rule, or quotient rule, you're going to begin calling it f prime.
All right, thank you.
Okay, so here's my cleaned up version of my derivative. I'm just going to plug -1 in to get my slope. Sorry, not 5. Sorry, I plugged in the wrong value up top here. Okay, 1 plus 2 is 3. -2 squared is 4. So there's my slope. So let me gather my information here. One slope form.
We need to expand that like the 3/4 times.
No, you never have to. If it's a point slope form, AP exam, they will give you full credit.
We allow
in
to
this form.
expand.
You can, yeah, you can, if you distribute and get it into slope intercept form, there won't be any points taken off. The only thing is be aware that you're taking an additional step, which takes more time. And if you make a mistake past this point, you could get points taken off. So just be aware of those. But if you want to keep going, there's no issues. Okay, any questions with, so there'll be a problem like this on the quiz where you're going to be using a derivative like quotient rule, finding the slope, and then maybe going a little further and finding tangent line equation. Okay, if you can turn to page 25, we're going to backtrack a little bit. Let me, I think there's, yeah.
There was, X1, wait, what's like the point slope form?
Yeah, here's the point slope form right here. Y minus y1 equals m times x minus x. There's also slope intercept form, which is y equals mx plus b. If you want to get into this form, you can, but typically this is the easier one to get to, so we can stop here. Okay, page 25. Okay, page 25. I want to address the specific type of question that we're going to see. Let's look at number 4 here. Okay. 4 says, if a particle moves along a line, according to the equation, S sub t equals t to the 5th minus 5t to the 4th for all real numbers, then how many times does the particle reverse its direction? So what we first need to find is, imagine an object moving left and right. Okay. If an object is going to reverse direction, first it has to do what momentarily? It has to stop, right? So we first have to figure out when the object is at a stopping point, and those are the markers that kind of potentially help separate our intervals. So whenever you're asked to find whether or when it changes direction, or what direction is moving in, or when's it moving left, or when's it moving right, anything dealing with motion is going to be coming from your velocity function. So your first thing you're going to do is you're going to find v of t. And then you're going to set your v of t equal to 0. Because it doesn't mean that the object stops indicates the object will change direction, but it is a prerequisite. So anytime we want to talk about direction or changing direction, or when's it moving left, when's it moving right, we always have to work with velocity, and we always have to set that equal to 0. Okay, so what's v of t equal to? What's the derivative? This is our position function here. Minus. Yeah. Okay, next step, you're going to set velocity equal to 0, and you're going to try to factor and solve for t. What's my GCF? 5t to the 3rd. Okay. And that leaves me with t minus 4. Okay, once I'm in factor form, I can solve for t. So what are my two t values? Yeah, t equals 0, and t is equal to 4. Okay, next up, you're going to create a velocity sign line. And we're going to call these critical points onto your sign line, 0 and 4. Now, a lot of times when we think about time, we think of time as greater than or equal to 0. But in this case, they're specifying t as all real numbers. So so for this problem, we're going to be looking at negative intervals as well. So basically, this object is going to be moving in some direction, and it's going to stop at t equals 0. And it's going to continue either moving in the same direction or changing direction, stopping at t equals 4. And then for the rest of the way, it's going to be moving in the same direction again. Okay. The way we can test these intervals is we're going to choose, because it's all consistent here, whether it's -1, -2, -3, we know that this object is going to be moving in the same direction. So I'm just going to test random points. Typically, I like to choose numbers close to 0 because those are the easiest ones to test. So I'm going to test -1. I could test -2, but -1 will do the job. Here, I'm going to test 1. And here, I'm going to test 5. I'm just going to plug -1 into my velocity function. And I don't care what number I get. I just care what sign I get. So if I plug -1 in for 5t cubed, I'll get a positive or negative? Negative. What's -1 minus 4? Is that positive or negative? Negative. 2 negatives makes positive. So that indicates that from -infinity to 0, this particle is moving to the right. And then wherever it ends up, it's going to be stopped at t equals 0. All right, next up, let's plug 1 into the velocity function. I like to plug into the factor form because I don't have to do a whole bunch of calculations. I can just count the signs. So if I plug 1 in for t, positive or negative? Okay, and then 1 minus 4, positive times negative is negative. Okay, so this object is going to move to the right. It's going to stop, move to the left for the next 4 seconds. It stops. And if I plug 5 into t, there's a test point here. 5 in for t, positive or negative? 5 minus 4, 2 positives makes. Okay, and then we just look at the signs here. These numbers don't matter anymore. We don't care about those numbers there. So we will say the particle reverses directions twice, right? Once at t equals 0 and once at t equals 4. Yes.
Like that.
Well, it's only asking for how many times it reverses direction. If I was asking when's it moving left or when's it moving, okay, yeah, let's do that. So let's say the problem says when's it moving to the right. So if you want to say interval where the object is moving right, you would say -infinity to 0, either do comma or union, and then again from 4 to infinity. And then when is the object moving left? It'll be from 0 to 4. Okay, the problem's not asking it, but I think that's a good connection since we're going to have to be able to do that as well. So create your velocity sign line, choose numbers to test, indicate plus and minus. Plus means right, negative means left. And if there's a change in signs, that means there is a change in direction at that moment in time. If there's no change in sign, then no change in direction. Let's do a more extended problem here. Page 26. So this could, yeah.
How many problems we're gonna have about like particle movement?
The quiz will be front and back. I don't know how many questions there are, but it's going to be just the front and back. It'll be like an extended problem like this, it'll be a quotient rule, a product rule, a power rule. Yeah, roughly that. Okay, so here's number 7. The position function of a particle is given by x of t, and x of t is the position function. That means x means is moving left and right along the x-axis. Okay, when is a particle at rest? So again, how do we interpret that? Particle at rest is when what? Velocity is 0. Yeah, so we're going to find velocity, set velocity equal to 0. Okay, set equal to 0. I can factor out the GCF of 6. One multiplies to be 10, adds it to be -7. Set both my parentheses equal to 0. So t equals what?
5.
Yeah, t equals 2 and 5. That's all we need. We don't. It's only asking for when the particle is at rest, so we can stop there. T equals 2 and 5.
6.
Well, technically, you're setting 6 equal to 0, but if you set 6 equal to 0, there's no solution there. So we can ignore it. Now, if there was a t sitting out there, then 0 would be a critical point. Okay, when is the particle reverse direction? Let's create our velocity number line. And you're just trying to figure out the motion, the direction of motion in each subinterval, either positive or negative. So you can choose any number you want, but I like to choose numbers. I mean, if I can involve 0, I find that to be easier. So you can choose 1 or 0. I'm going to choose 0 here. I'll choose 3 here, and I'll choose 6 there. These numbers are not going to be part of my interval. They're just test points to help me figure out what the signs are. So I like to plug it into the factored form. It's easier, less calculations. So if I plug 0 in for t, positive or negative? Negative. 0 minus 2, negative. 2 negatives makes positive. Okay. Plug 3 in. 3 minus 5, negative. 3 minus 2, positive. Negative times positive is negative. Okay. Plug 6 in for t, positive. Positive. So how many times does a particle reverse direction? Twice, yeah. Once at 2, he's moving right, then he moves left. That's 1 change of direction, and then on either side of 5. Now, once you test once you get those plus and minus show up, these numbers don't mean anything. So I think sometimes we can get distracted by those numbers in our intervals. So. Okay. Let's not worry about these for now. Number 8. V of t function is given to you. When will the particle be at rest? So what's our strategy there? Set v of t equal to 0. Do we need to find the derivative?
No.
No. So that's nice, right? Everything's already in factored form. Just have to set that equal to 0 and solve for t, right? So t equals what?
5.
5, 3, and 1. Okay. When is the particle moving left? When is the particle moving right? When does the particle changing direction? We're just going to create a velocity sign line, get all of our critical points and our plus or minuses show up. And then we just read everything off of our velocity sign line. So here's my velocity sign line. Okay, I'll test numbers that are as close to zero as possible within each subinterval, and I can just plug it all into my factored form. Okay, so we just care about the signs. Okay, so 0 in for t. What do I get here? Negative, positive, negative. So 2 negatives makes positive. And also, I think from now on, we can ignore that t minus 3 squared because why? It's always positive, so it's not going to impact the signs. So I mean, you can plug in, but just know that it's always positive. So I'm just going to just test the first and third one. Okay, I'm going to plug 2 in. 2 minus 5, negative. 2 minus 1. So negative times positive is negative. Okay, so it's moving left in this interval. Plug 4 in, negative, positive, which is negative. Plug 6 in, positive, positive. So when is a particle moving left? So for left, we can say from 1 to 3, and then union or comma 3 to 5. And the reasoning is because velocity is less than 0. When does a particle change direction? Change direction. Yeah.
Why could you write it as 1 consecutive?
You mean like from 1 to 5? Because at 3 is neither moving left or right, so we need to have a copy balance. At 1 and 5, yeah, right.
Since we reverse direction twice.
Yes, reverse direction twice. Yeah, change the direction twice. Guys, no homework tonight. Tomorrow, we'll just pick up with quiz review. We'll spend all class period doing quiz review. Okay. All right, you guys can get your phones and head down. Thank you.
Well, now I'm laughing because I thought I was.
It was way too. It was like, it sounded like Robert.
Maybe sort of involved. Oh, thank you.
Can I just put her in that package that's ready tomorrow? I just, oh my God.
Thanks.
Well, the big question on the quiz that goes, we have to do it, first one they got.
Definition.
Maybe I'll.
Yes, no, but we'll talk about something like that, but it may not be what else to go.
I have a meeting every Thursday in a bunch of people. I have to go to.
Is there a pass that you can maybe just show her once saying, hey, this is okay?
Okay, so go to her today.
Yeah, go to today. Do you have a pass? That,
No, I don't. Like,
Okay.
I could get one
yeah.
after the meeting.
Yeah.
Good.
So eventually we show her, but hey, I'm meeting every advisement and everything.
Yeah, so should I go to her right now or should I wait and get the pass and then go to her after?
United States of America and to the
Don't get the
republic for which it
pass
stands,
and go to her.
one nation,
Thanks.
under God,
Thank you.
indivisible, with liberty and justice for all. It's called the last reflection. Thank you. Attention new students to Milton High School. Today is our new student breakfast, starting right up to this announcement. Eligible students receive their passes to this event. Please show this pass to your teacher or this email to your teacher, and we'll see you during advisement.
Hey guys, it's your mom volleyball team. Create the big region match today against Gainesville. Stay be at 5, first be at 6. Show up, show out for your teacher appreciation at D level.
Today's inspirational quote comes from the Dalai Lama. Choose to be optimistic. It feels better. Have a great Thursday. And remember, every day is a great day to be a Built Eagle.